January 1942. Inside the vast steel belly of the Detroit Arsenal tank plant, the night shift moves like a tired, determined organism. Floodlights hang from the rafters, casting pale halos over rows of half-assembled Sherman tanks whose cold armor plates glisten with fresh weld burns. The air tastes of cutting oil and hot metal, thick enough to cling to the back of the throat. Overhead, cranes rumble along their tracks, chains clinking as they haul turret rings into place. Sparks shower from a welding booth, scattering across the concrete like brief orange stars before fading into darkness. Workers in heavy coats wipe their brows despite the winter chill, pushing to make numbers that still fall short of the Army's demands. Engineers argue over charts clipped to boards, pointing at delays no one seems able to solve. And in the middle of this mechanical storm, moving almost unnoticed through the cluttered aisles with a push broom and a dented metal dustpan, a night shift janitor pauses. He watches how workers dodge piles of scrap, how parts are carried in circles, how minutes bleed away with every unnecessary step. His idea is simple, almost laughable. Yet in a war measured in hours and steel, even a ridiculous shortcut might change everything. And so begins the story of how one overlooked insight could help Sherman tanks roll off this floor twice as fast. The world that shaped the Detroit Arsenal tank plant was one sliding rapidly into chaos. In 1940, Europe had witnessed a military collapse so swift it stunned even seasoned generals. German armored columns cut through Belgium and France with a speed that seemed impossible, their panzer divisions tearing across open country in coordinated strikes that left defenders paralyzed. By June, France had fallen. Britain, bloodied and cornered, stood alone across the Channel. Newspapers in the United States printed photographs of wrecked French tanks and burning cities, and the grim realization crept across the American public that this new kind of mechanized war was unlike anything the world had prepared for. The U.S. Army, still clinging to outdated equipment from the First World War, possessed only a handful of modern armored vehicles, and none in the numbers required to confront a force trained and equipped for lightning-fast assault. The message was clear. If the United States was going to survive the century taking shape before its eyes, it would need to build not dozens, not hundreds, but tens of thousands of tanks, machines that would move with the speed, firepower, and endurance demanded by the brutal arithmetic of global conflict. As military planners grappled with this reality, President Franklin Roosevelt delivered a speech that would come to define the nation's industrial purpose. In December 1940, he called on America to become the arsenal of democracy, a phrase that captured both urgency and ambition. The United States would not merely supply its own military, it would arm the free world. But this promise posed a problem few in Washington yet understood. America did not have factories designed to build tanks. Cars, yes. Tractors, yes. But tanks were a different breed entirely, heavy, armored, intricate, and unforgiving of error. Conversion of automobile plants was possible, but wartime engineers feared it would not be enough. The Army Ordnance Department needed something unprecedented, a plant built from the ground up to manufacture armored vehicles at a scale no nation had ever attempted. And so, in early 1941, the Army turned to the one industry that knew how to move massive quantities of steel with speed, Detroit. When the contract landed in the hands of Chrysler Corporation, many outsiders doubted whether an automobile company could master the brutal requirements of armored warfare. But inside Chrysler's executive offices, men like K.T. Keller understood the gravity of the challenge. They hired the legendary industrial architect Albert Kahn, whose factories had already shaped much of America's automotive skyline, and asked him to design a new kind of facility, a fortress of production. The result was the Detroit Arsenal Tank Plant, an immense concrete and steel structure sprawling across more than 100 acres in Warren, Michigan. Its reinforced walls were built thick enough to survive potential air raids. Its assembly halls were vast enough to swallow entire city blocks. And at its heart lay a promise that within these walls, the United States would learn to build tanks with the same efficiency that Detroit once built cars. But the early months proved far from smooth. The first tanks to roll from Chrysler's lines were not the famous Shermans, but their predecessor, the M3 Lee, a tall, awkward design rushed into service to meet immediate wartime needs. Production was slow. Skilled labor was short. Suppliers struggled to deliver armor plate with the precision demanded by military specifications. Army inspectors haunted the plant floor, rejecting welds and components that failed to meet their exacting standards. Every misalignment of a gear tooth, every faulty weld bead, every missing bolt meant hours, sometimes days, of lost progress. Workers trained in automotive assembly now found themselves wrestling parts that weighed 5 times more, required tighter tolerances, and bore far higher consequences for failure. The nation was learning, painfully, that mass-producing tanks was not merely a scaled-up version of mass-producing cars. Yet beneath the frustration, something else was happening, something that would define the rest of the war. As Chrysler engineers refined their processes, as workers adapted to unfamiliar tasks, as foremen reorganized workflows through trial and error, the rhythm of production slowly stabilized. Mistakes became lessons, and lessons became systems. The vast spaces of the arsenal began to hum with a new kind of disciplined urgency. Welders gained confidence. Crane operators mastered the delicate swings of turrets and hulls. Inspectors found fewer flaws to circle in red pencil. And yet, even with all this progress, production numbers lagged behind the deadlines Washington demanded. The Army needed more tanks, faster tanks, tanks that could reach Europe and the Pacific in quantities the Axis could never hope to match. Chrysler's assembly lines were running hard, but not hard enough. Somewhere inside this industrial maze, a crucial set of inefficiencies still lay hidden, waiting for the eyes that would see them. And it is at this moment, when the need is greatest and the pressure absolute, that the smallest observations begin to matter, shaping the lines and routines of the factory in ways no designer could have predicted. As 1942 unfolded, the U.S. Army made a pivotal decision that would reshape the demands placed on the Detroit arsenal. The M4 Sherman would become America's primary medium tank. It was not the heaviest tank of the war, nor the most armored, nor the most technologically advanced. But it was something far more valuable. It was a machine designed to be built. Its welded hull reduced the time and labor once required for riveting. Its engine options drew heavily from existing American automotive technology. Its suspension, transmission, and turret systems were modular enough to be produced by numerous suppliers across the country. In an age where the battlefield was consuming machines faster than factories could replace them, the Sherman's greatest strength was its manufacturability. For Chrysler, the transition from producing the M3 to the new M4 offered both a strategic opportunity and a formidable challenge. Every part of the plant had to evolve. Tooling, assembly jigs, supply lines, welding techniques, and even the ways workers were trained. The promise of the Sherman lay in its potential to roll off the line in unprecedented numbers, but only if Detroit could unlock a level of efficiency it had not yet reached. Inside the arsenal, the changeover forced a kind of controlled chaos. Old fixtures were torn out. New templates were bolted to the floors. Engineers raced to update blueprints. Suppliers across the nation struggled to synchronize deliveries of armor plates, powertrains, and turret components with the plant's evolving schedule. And on the floor itself, thousands of workers, many with only a few months of industrial experience, found themselves adapting to new tasks almost weekly. Women who had been hired as inspectors were suddenly retrained as welders. Farmers who had never set foot in a factory now operated heavy presses. Migrants who had come north in search of wartime employment were thrust into the heart of an industrial experiment unlike anything the world had seen. The Army demanded speed, Chrysler demanded precision, and the workers were caught between them, learning by doing, failing, and doing again. What emerged was a factory that operated as a living organism, evolving constantly as it chased the production targets set in Washington. Yet even as the Sherman's design simplified many aspects of assembly, the Detroit arsenal still struggled to reach the volumes military planners envisioned. Bottlenecks appeared everywhere. Turret installations ran behind schedule because crane operators were forced to navigate cramped aisles. Welding crews idled while waiting for sub-assemblies that arrived late or in the wrong order. Some components were stored too far from the stations where they were needed, forcing workers to walk long distances or weave through cluttered pathways. Scrap metal piled up faster than crews could remove it, narrowing aisles and slowing forklift traffic. The factory had been built for speed, but speed could not be achieved until every step, every lift, every weld, every movement across the floor was refined into a seamless flow. Engineers studied blueprints and timing charts, but the reality on the ground rarely resembled the neat diagrams pinned to office walls. The true obstacles hid inside the lived routines of the workers themselves. Despite the challenges, the plant began to show signs of what it could accomplish. Production numbers crept upward each month. Weld seams grew cleaner. Assembly teams became more synchronized. Wherever a problem became obvious, Chrysler sent engineers to the line to adjust fixtures or streamline procedures. But this problem-solving approach had limits. Engineers saw the process from above. Managers saw it through reports. Army inspectors saw it through flaws and rejections. Only those who lived every shift in the hum and heat of the assembly halls, the sweepers, the crane tenders, the tool runners, the station hands, truly understood how the line moved, where it stalled, and where minutes vanished unnoticed. And in a plant producing machines that weighed 30 tons, even a few lost minutes per tank could accumulate into days of wasted labor each month. What made the Detroit arsenal unique, and what set the stage for the story at the heart of this documentary, was the culture that began quietly forming beneath the noise of machinery. Chrysler, pressured by the Army to increase output, opened itself to ideas from every corner of the workforce. Suggestion boxes appeared. Floor supervisors encouraged workers to speak up. Posters reminded employees that one idea can win the war. Most suggestions were small and incremental. A handful were rejected outright, but others revealed inefficiencies so entrenched they had become invisible to those in positions of authority. And among the thousands of workers moving through the arsenal every day, some possessed an uncommon gift. They saw the patterns that others stepped over. This was the environment into which our janitor walked each night, an industrial battlefield where time itself was the enemy. He pushed his broom through aisles crowded with components, navigated around carts piled with armor plates, and watched workers circle obstacles that should never have been there. He cleared scrap from beneath welding stations and saw how often freshly cut pieces were dropped far from the disposal bins. He noticed how certain teams had to wait because the parts they needed were routinely buried behind clutter. No engineer had asked him for his opinion, yet he saw, with untrained but honest eyes, a flaw that slowed the entire plant. And in a place where production speed meant survival for soldiers overseas, what he saw would matter more than anyone yet realized. The human story of the Detroit Arsenal tank plant begins not with generals or engineers, but with the people who filled its cavernous halls day and night, an army in overalls whose labor shaped the war as surely as any battlefield maneuver. Among them were seasoned machinists who had left automobile plants to answer the nation's call, young men medically unfit for combat, but determined to serve in whatever way they could, and women stepping into industrial roles for the first time. The arsenal drew workers from every corner of the country, farmers from the Great Plains, migrants from the South, and recent immigrants from Europe who understood firsthand the stakes of the war. Together, they formed a workforce as diverse as the nation itself. For many, the job was grueling beyond anything they had imagined. The clang of steel, the hiss of welders, and the rumble of cranes were constant companions. Shifts lasted long into the night, Saturdays blurred into Sundays, and hands blistered beneath heavy gloves. Yet despite the fatigue, there was pride in building something that mattered, something destined for soldiers facing unimaginable dangers on the other side of the world. And within this mass of humanity were individuals whose roles seemed insignificant on paper, but proved essential in practice. Sweepers who kept pathways clear, tool runners who ensured stations never ran dry, and janitors whose quiet routines carried them through every part of the building, granting them a wider view than almost anyone realized. Technologically, the Sherman tank represented the industrial philosophy that allowed the United States to outproduce its enemies. It was not designed to be perfect. It was designed to be producible. Its components were standardized so that factories across the nation could manufacture them without requiring specialized craftsmanship. Suspension units, transmissions, and turret components could be bolted onto any hull from any assembly line. That interchangeability reduced delays and eliminated the bottlenecks that plagued more complex designs. The welding process, refined repeatedly in the arsenal's early months, allowed armor plates to be joined more quickly and reliably than riveted methods used in earlier tanks. Overhead cranes enabled the plant to move 30-ton hulls with a precision that would have been unthinkable a decade earlier. Even the way parts were stored reflected this technological philosophy, organized in vast racks that resembled warehouses more than workshops. And yet, for all this engineering, efficiency remained elusive. Machines were only as effective as the people who operated them, and even the best designed workflow could be slowed by a misplaced cart, a cluttered aisle, or a delay in delivering essential components to the right station at the right moment. Beyond the machinery itself, the process by which tanks were assembled became a groundbreaking lesson in industrial evolution. Chrysler's engineers attempted to apply the logic of automobile mass production to armored vehicles, breaking down the assembly of a tank into discrete, repeatable tasks. The goal was to treat the tank not as a hand-built war machine, but as a system of sub-assemblies flowing smoothly toward completion. Hulls were welded in one bay, engines prepared in another, turrets assembled in a third. Ideally, each component would arrive at precisely the right point on the line at precisely the right moment. But reality seldom matched the ideal. Welding crews might finish ahead of schedule, only for turret teams to fall behind. Engine mounts could be delayed by a shortage of fasteners or miscommunication between shifts. Scrap metal sometimes piled up faster than crews could remove it, restricting movement and forcing workers to improvise. Managers walked the floor each day searching for inefficiencies, but no matter how many charts they created or how many hours they spent observing stations, some problems remained stubbornly hidden. The plant's complexity made it almost impossible for any one person to see the full picture, except, perhaps, for those whose jobs carried them continuously from one end of the building to the other. This is where the janitor's position becomes remarkable. While engineers studied blueprints and foreman-monitored stations, the janitor's nightly routine took him through every corridor, past every storage rack, between every machine, and around every obstacle. He saw welders forced to detour around piles of scrap. He watched workers from one station cross paths with those from another, each carrying heavy components that should never have required such travel. He noticed that certain aisles clogged at the same times every night, while others remained inexplicably empty. He swept shavings from beneath cutting machines and wondered why the bins meant to catch them were placed too far for where the work was done. These were observations invisible to those who focused only on production numbers or machine output. They were the lived details of the factory floor, details that revealed the difference between an operation functioning at capacity and one functioning at potential. And they set the stage for an insight so simple it seemed almost foolish, yet powerful enough to ripple across an entire production system. Leadership at the Detroit Arsenal tank plant operated under a pressure unlike anything American industry had experienced before. Executives such as K.T. Keller at Chrysler understood that their role extended far beyond business. They were now central figures in the nation's survival. Keller, alongside Army ordnance officials, pushed relentlessly for improvements, demanding that every department find ways to cut minutes, save material, and increase output. Yet what distinguished the Arsenal's leadership was not only its insistence on discipline, but its willingness, sometimes grudgingly, sometimes enthusiastically, to listen. The plant began adopting suggestion programs, encouraging anyone, regardless of rank or role, to offer ideas for improvement. Posters hung on walls proclaiming, "Your idea can help win the war," and supervisors were instructed not to dismiss proposals without review. Of course, many suggestions were impractical or redundant, but a surprising number revealed insights managers had overlooked. Engineers knew process diagrams. Workers knew lived reality. And in a facility so complex that one misaligned cart could ripple into hours of lost productivity, leadership slowly came to accept that the best innovations often emerged from those who saw the obstacles up close, not from offices high above the factory floor. Across the Atlantic, the enemy offered a stark contrast, one that further clarified why American production innovations mattered so profoundly. German tanks, like the Panther and Tiger, were formidable machines built with an emphasis on power and protection. But their complexity, while impressive on paper, proved a liability in the brutal calculus of wartime production. These tanks required specialized parts, skilled labor, and long assembly times. Germany's factories were strained, fragmented, and increasingly vulnerable to Allied bombing. Even when a Panther outmatched a Sherman in a head-to-head engagement, the broader strategic picture looked very different. The United States could produce multiple Shermans in the time it took Germany to build one Panther. The result was a battlefield dynamic shaped not only by armor and firepower, but by industrial tempo. American armor divisions could replace losses quickly, restore strength between operations, and maintain offensive pressure. German units, in contrast, often received replacements too slowly to recover momentum. Thus, even small improvements in the Detroit arsenal's efficiency, whether from an engineer's redesign or a janitor's sharp-eyed observation, translated directly into strategic advantage. Each saved minute became a reinforcement shipped overseas. Each eliminated bottleneck became another tank rolling off the line. Yet there was another dimension to this industrial story, one rooted in the social fabric of wartime America. The arsenal's workforce was a mosaic of backgrounds, identities, and economic realities. People who might never have crossed paths in peacetime now stood shoulder to shoulder beneath the glow of welding torches. Women, who had long been confined to domestic roles or lower-paid occupations, entered heavy industry in unprecedented numbers, proving themselves indispensable at every station, from machining to inspection to welding armor plates. Immigrants who had once struggled to find work now contributed directly to the fight against regimes that threatened their homelands. African American workers, though still facing discrimination, pushed into new industrial positions through the pressure of civil rights advocates and the demands of wartime necessity. In this sprawling community, social hierarchies blurred. A janitor could offer an insight that an engineer had overlooked. A tool runner could identify a pattern no supervisor had noticed. The war compressed these lives into a single mission: build the machines that would defend the world. This moral dimension gave the janitor's eventual insight its deeper significance. He was not a figure appointed to lead, nor a specialist trained in engineering. He was, in every external sense, unremarkable, a worker whose name would never appear in factory reports or military records. But the war had created a moment in history when ordinary people carried extraordinary responsibility. The tanks built in Detroit would go on to fight in deserts, forests, mountains, and cities. They would protect infantry, break enemy lines, and absorb the fire of anti-tank guns meant for American soldiers. The janitor, sweeping metal shavings from the floor, understood this in his own quiet way. He saw the urgency in the faces of workers who knew men were dying overseas. He recognized that wasted time in the factory meant delayed armor on the battlefield. And he grasped, perhaps more instinctively than those with advanced degrees, that efficiency was not simply a matter of charts and schedules. It was a matter of human lives. This recognition framed the insight that would soon influence the assembly line. It was not brilliance born of textbooks, but clarity born of observation, repetition, and unfiltered perspective. The janitor saw patterns others ignored because he had no reason to assume they were normal. He noticed inefficiencies that supervisors dismissed because he was not invested in defending past decisions. And he understood the rhythm of the plant, not from brief inspections, but from hours spent walking, moving, weaving through the physical reality of the arsenal. In a war that demanded innovation from every corner of society, his ridiculous idea would become one of the countless invisible contributions that helped American production surge beyond anything its enemies could imagine. And as the plant approached its breaking point under escalating quotas, it was precisely this kind of insight, humble, practical, and rooted in experience, that the arsenal needed most. By the middle of 1942, the Detroit Arsenal tank plant had become a place where every second mattered. Production quotas rose faster than the lines could adapt, and with each new request from Washington, the gulf between expectation and reality widened. Managers walked the floor with stopwatches, engineers revised workflow diagrams late into the night, and Army inspectors demanded improvements with an urgency shaped by battlefield losses overseas. Tanks were arriving too slowly in North Africa. Crews needed replacements. Commanders needed reserves. While newspapers spoke proudly of America's industrial might, the quiet truth inside the arsenal was that the output still lagged behind what the war demanded. In some weeks, entire sections of the line fell behind schedule because a single subassembly arrived out of order, or because a crane operator had to navigate around obstacles that no one had thought to remove. These delays, often just minutes at a time, accumulated relentlessly. The plant's leadership knew they were close to unlocking the full speed the facility was designed for. But something remained off, something hidden in the ordinary flow of the factory floor. It was in this high-pressure environment that the janitor's routine took on unexpected significance. Every night he walked the same path, down the long center aisle past welding bays, across the turret installation zone, into the storage racks where engines were staged, and finally around the hull assembly pits where sparks rained down like fiery snow. He swept up metal shavings, cleared tangled wires, emptied overflowing scrap bins, and wiped oil spills that threatened to trip workers carrying heavy components. And each night, he noticed the same pattern repeating itself. Workers carrying subassembly parts from the storage racks to the installation stations were forced to weave around piles of scrap metal waiting to be hauled away. Carts filled with components lined the walls, but often stood in the wrong order, forcing welders to search for the items they needed. Crane operators paused repeatedly as workers stepped into their paths, creating brief but frequent interruptions. Nothing about these moments appeared dramatic, but to the janitor who saw them accumulating night after night, they formed a picture far clearer than any engineer's diagram. The factory was losing time not because of major mechanical failures, but because of dozens of small, predictable, preventable obstacles. One night, while sweeping near the hull welding stations, he noticed something striking. Workers installing side armor plates often had to wait for a crane to move a turret ring that had been staged directly in their path. The turret rings, heavy and awkward, were delivered early in the shift and placed in a convenient open space. Convenient, at least, from the perspective of the delivery crew. But this placement forced the welding team to slow down, detour, or pause entirely whenever the crane operator had to maneuver the ring out of the way. The janitor watched this happen again and again. Workers cursed under their breath, supervisors checked their watches, and yet no one questioned the root of the delay. It wasn't sabotage or poor training. It was simply the inertia of habit, things placed where they had always been placed, regardless of the consequences. The janitor's ridiculous idea emerged almost by accident. While emptying a scrap bin, he traced in his mind the movement patterns of workers, cranes, and carts. He realized that if the target areas for scrap disposal, part staging, and crane loading were shifted just a few yards, sometimes only a few feet, the flow of the entire line would change. Workers would walk straighter paths. Cranes would swing more freely. Scrap would be removed without blocking aisles. What seemed minor in isolation could save minutes in every hour, hours in every day, and days in every month. He hesitated. After all, he wasn't an engineer. He wasn't a supervisor. He was a janitor. Who would take seriously the idea of a man whose job was to sweep floors and empty bins. But war compresses hierarchies. In the arsenal, value came not from one's title, but from whether an idea could save time. And so, with a mixture of caution and determination, he approached a foreman he had often spoken to during breaks. At first, the foreman chuckled. Moving scrap bins and shifting part racks hardly sounded like the kind of innovation the line desperately needed. But the janitor insisted. He described what he saw each night: the unnecessary delays, the blocked aisles, the repetitive detours, the idle moments that multiplied quietly in the shadows of the plant. The foreman listened longer than expected. Then, with a shrug, he agreed to test the idea during the next shift when traffic on the line was lighter. The results were immediate. With scrap bins moved away from choke points and part racks reorganized according to the sequence of installation, workers moved more efficiently. Crane operators completed lifts without delays. Welders no longer had to stop to navigate around clutter. Even small tasks, fetching tools, delivering components, positioning hull plates, became smoother. The foreman ran the numbers the next morning and found that a process that ordinarily consumed hours had contracted noticeably. The difference amounted to only minutes per tank, but those minutes, multiplied across hundreds of vehicles and thousands of shifts, hinted at staggering potential. Word traveled upward. Engineers reviewed the change, then quietly admitted that none of them had noticed the problem because none of them walked the floor the way the janitor did. Management authorized a broader trial, shifting layouts throughout the assembly bays. The cumulative improvement stunned everyone, and it was only the beginning. The expansion of the janitor's idea began quietly, almost cautiously, as Chrysler engineers and Army ordnance inspectors observed the initial trial with a mixture of curiosity and skepticism. But the data could not be denied. By simply rearranging scrap bins, reallocating storage zones, and clearing pathways that had been obstructed for months, the assembly rhythm improved in ways no blueprint revision had ever achieved. Crane routes became smoother. Workers stopped tripping over clutter or navigating around misplaced carts. Sub-assemblies began arriving in a cleaner sequence, reducing the frustrating periods of waiting that once plagued the line. Even experienced welders, men who rarely commented on management decisions, remarked that the job suddenly felt less tangled. The transformation was subtle, almost invisible to the untrained eye, yet unmistakable in its effect. The plant felt faster, lighter, more coordinated, as if a knot that had tightened over months of production had finally begun to loosen. Once supervisors confirmed that the improvement was not a fluke, they ordered the change extended across multiple bays. This required long nights of remapping floor space, relocating storage racks, and reassigning disposal points. Some workers resisted at first, frustrated by the disruption to their routines. But as the new workflow settled, the results spoke for themselves. Assemblers found themselves waiting less and working more. Inspectors recorded fewer delays. Material runners, once exhausted from constant zigzagging, completed their routes in less time and with fewer errors. The plant's internal transportation, the unseen circulatory system that moved parts, tools, and equipment, grew more efficient with each refinement. Engineers soon realized that the janitor's insight had revealed a larger truth. The arsenal's greatest obstacles were not flaws in machinery or deficiencies in manpower, but the invisible patterns of movement that governed how people and parts interacted. When those patterns were optimized, the factory itself seemed to breathe more freely. The numbers that followed confirmed what the workers already felt. Within weeks, the average time a tank spent on the assembly line decreased. At first by a sliver, 10 minutes here, 12 minutes there. But those minutes accumulated with startling speed. A process that once required hours was now measured in far less. And as the assembly line grew smoother, the plant's overall monthly output began to climb. By the end of 1942, the Detroit Arsenal tank plant reached a wartime peak. 896 Sherman tanks produced in a single month, an achievement that stunned officials in Washington and rattled Axis analysts who monitored American industry with growing unease. The Army, once doubtful that the plant could meet its initial quotas, now began planning offensives with the confidence that tank losses could be replaced faster than the enemy could destroy them. To describe this leap simply as an engineering triumph would be to misunderstand its essence. The speed increase was real. Sherman production, measured in labor hours per vehicle, had effectively been cut in half compared to the earliest months of the war. But the improvement did not come from a single dramatic innovation. It came from compounding efficiencies, the Janitor's layout change, refinements to welding fixtures, faster turret mating, smoother engine installation, better sequencing of parts delivery, and a workforce increasingly skilled at anticipating one another's movements. Yet the Janitor's contribution symbolized something extraordinary: the acknowledgement that a massive industrial machine, powered by thousands of hands, could be transformed by the quiet insight of someone who simply paid attention. Far from the factory floor, the impact of this transformation resonated intensely across the world's battlefields. In North Africa, American armored units recovering from early setbacks suddenly received Shermans in numbers that allowed them to replace losses within weeks rather than months. In Sicily and Italy, fresh tanks arrived even as others were destroyed in combat, enabling Allied forces to maintain the relentless pressure required for offensive momentum. By the time the Allies landed in Normandy in 1944, the United States had become the world's foremost producer of armored vehicles, capable of absorbing battlefield attrition on a scale Germany could never counter. Eisenhower would later reflect on the beaches of Normandy, where wrecked American tanks lay scattered across the sand, that each destroyed Sherman symbolized not a catastrophe, but a reassurance. The United States could replace every tank faster than the enemy could destroy it. On the German side, the shock was profound. Reports from the eastern and western fronts complained of American armored formations replenishing strength with bewildering speed. German commanders, accustomed to ration production and chronic shortages, found themselves facing an opponent whose industrial capacity seemed limitless. The technical superiority of the Panther or Tiger mattered less when American armored divisions always returned to full strength within a campaign's timeframe. Victory in war is often attributed to strategy, firepower, or leadership. But in truth, it is sustained by logistics, and the logistical miracle unfolding in Detroit was rapidly shaping the future of the conflict. Back at the arsenal, few workers knew precisely how much their efforts mattered, but all sensed that something had changed. The assembly line flowed more smoothly, morale lifted, and the plant's confidence grew. Posters praising worker suggestions appeared more frequently. Supervisors, once dismissive of ideas from the lower ranks, now listened more carefully. The janitor himself returned to his quiet routines, rarely credited, rarely acknowledged, but forever linked, whether he knew it or not, to a turning point in the plant's history. His idea had been simple, almost laughable in its modesty, yet revealed what war demanded most: clarity, courage, and the willingness to notice what others ignored. And as the arsenal continued to refine its processes, the consequences of that clarity would ripple outward, shaping not only the machines built within those concrete walls, but the very speed at which the Allies moved toward victory. When the improvements fully settled into the Detroit arsenal's routine, their impact became measurable not only in the plant's internal reports, but across the entire Allied war effort. Production figures began to rise with a momentum that astonished military planners. In 1941, American tank output was modest, almost experimental. By late 1942, the United States was producing armored vehicles at a rate the Axis could neither match nor counter. Detroit alone accounted for tens of thousands of tanks, and the arsenal became the centerpiece of this transformation. The Sherman, once criticized for its mechanical simplicity, became the backbone of Allied armored forces. And though the line improvements had begun with something as unglamorous as reorganizing floor space and clearing pathways, the effect on labor hours per tank was unmistakable. Processes that once consumed whole shifts were compressed into fractions. Subassemblies arrived on time. Installation teams worked without interruption. What had once been chaos slowly crystallized into a predictable rhythm of steel, fire, and motion. This increase in efficiency translated directly into battlefield strength. When American forces entered Tunisia in late 1942, they faced an enemy seasoned by years of desert warfare. Early encounters revealed painful shortcomings: inexperienced crews, unfamiliar terrain, and equipment losses that mounted faster than replacements arrived. But soon the arsenal's accelerated output changed the landscape. Units battered in combat were resupplied with Shermans at a pace the Germans had not anticipated. Where a German panzer division might receive only a handful of replacements after a costly engagement, American units could be rebuilt to near full strength within weeks. This logistical advantage gave the Allies something their opponents lacked: resilience. A battle lost no longer meant a campaign lost. Tanks destroyed in North Africa were replaced before the next offensive. Machines burned out in Sicily were restored by the time Allied forces pushed into Italy. Behind every armored assault, behind every restored division, behind every rejuvenated spearhead was the silent machinery of Detroit. The strategic implications were enormous. Allied commanders, especially those planning large-scale operations, began to rely on the certainty that armor would arrive in the quantities required. In England, as the invasion of Normandy approached, docks filled with row upon row of Sherman tanks, fresh from American factories, cosmolines still coating their hulls. And the confidence that these machines provided was not merely psychological. It altered battle calculus. American generals planned offensives with the understanding that tank losses could be absorbed, that units would not collapse from attrition, that the momentum of mechanized warfare could be sustained even in the face of fierce resistance. This was a luxury the Germans, stretched thin across continents and starved of industrial capacity, could never enjoy. The numbers themselves painted the clearest picture. By war's end, the United States had produced nearly 50,000 Sherman tanks. A staggering portion of these came from plants like the Detroit Arsenal, whose monthly outputs sometimes matched or exceeded annual totals from Axis nations. Behind these statistics lay thousands of invisible contributions: welders who tightened their seams, machinists who honed components to tighter tolerances, supervisors who learned to trust worker insights, and yes, janitors whose quiet observations reshaped the paths through which steel flowed. The arsenal had become more than a factory. It was a symbol of what American industry could achieve under pressure, a place where innovation rose not only from laboratories or drafting tables, but from the lived experience of ordinary men and women determined to do their part. And although workers rarely saw the front lines, they understood that their labor carried weight. Letters arrived from soldiers praising the durability of the Shermans they fought in. Newspapers celebrated production milestones with photographs of smiling crews posing beside freshly painted tanks. Each achievement fed a sense of collective purpose. Even as shifts remained long and the plant's demands unrelenting, morale grew stronger. The line was no longer simply a job. It was a contribution to victory, a lifeline to men fighting an ocean away. But war is always moving, always consuming, and even as output soared, new challenges emerged. The arsenal could not pause to admire its success. The conflict pressed onward, demanding more machines, faster turnaround, and even greater precision. Yet the foundation had been laid. The plant was no longer an improvisational experiment, but a disciplined industrial force, capable of sustaining the war effort at its most critical moments. And the small insights that had set this transformation in motion, insights born from the unlikeliest sources, continued to ripple outward, shaping decisions and refining processes long after the initial suggestion had been made. The question now was not whether the arsenal could keep up with the war, but how its achievements would shape the conflict's final years, and what traces of this effort would remain once the guns fell silent. When the war finally shifted decisively in the Allies' favor, the Detroit Arsenal tank plant stood as one of the clearest symbols of America's industrial triumph. Yet victory did not bring an immediate quiet to its immense concrete hulls. as troops fought their way through France and toward Germany's industrial heartland. Demand for tanks continued at a ferocious pace. Shermans were lost to mines, ambushes, anti-tank guns, and the grinding wear of relentless offensives. Replacements still needed to arrive in vast numbers, and the arsenal continued to deliver month after month. Only in 1945, as Allied armies crossed the Rhine and German resistance began its final collapse, did production finally slow. The end, when it came, felt strangely anticlimactic. One month the plant thrummed with unbroken urgency. The next, machines fell silent, assembly lines emptied, and the ceaseless flow of steel paused for the first time in years. Workers who had spent half a decade living by whistles, shift bells, and the roar of welding torches now faced an unfamiliar quiet. Many returned to their pre-war lives. Others moved to new industries, and some stayed on as the government debated what the future of the massive facility should be. Post-war America entered a world reshaped by its own industrial might, and the arsenal was no exception. When the Korean War erupted in 1950, the plant was reactivated, once again filling with workers and machinery as the United States raced to equip its forces for a conflict in a distant land. New tank models replaced the Sherman on the assembly line, reflecting advancements in armor, firepower, and mobility. Yet the underlying lessons forged during the frantic years of World War II endured. Processes were designed with flow in mind. Plant managers remembered how small inefficiencies could snowball into major delays. The idea that insights could come from any level of the workforce remained woven into the factory's culture. Even as new welding technologies emerged and heavier tanks demanded more complex equipment, the spirit of continuous improvement, born during the early, desperate days of wartime production, remained central to how the arsenal operated. Over the decades that followed, the plant continued to evolve. Some sections shut down, others were modernized, and parts of the facility were eventually converted for civilian use. What had once been a fortress of wartime manufacturing gradually transitioned into a quieter industrial landscape. Yet traces of its history lingered everywhere. The crane tracks still embedded in the ceiling beams, the deep concrete pits where holes were once assembled, the echoing halls where thousands of workers had shouted instructions over the roar of machines. Former employees who visited years later described a strange sensation, as if the plant itself held the memory of its wartime rhythm. The urgency, the purpose, the relentless drive to outpace an enemy an ocean away. The contributions of workers like the janitor, whose simple observation had helped spark a transformation, did not survive in official records. There were no medals, no formal acknowledgments in government reports, no plaques bearing his name. His story lived only in recollections passed along informally, in a shared understanding among workers that improvements often came from places management least expected. And in that sense, his anonymity reflects a truth about industrial warfare. Countless individuals shaped victory through gestures that history rarely records. Their suggestions, insights, and decisions, many made in silence, many dismissed before they were appreciated, became threads woven into the broader tapestry of the war effort. The janitor's idea was not unique in its scale, but it was emblematic in its impact. It represented the power of perspective and the value of paying attention to the smallest details in a world where minutes lost could translate into lives endangered. By the time the plant finally ceased tank production for good and transitioned into a new era, its legacy was already secure. It had produced more tanks than any facility in American history. It had given the Allies the armored strength required to sustain long, brutal campaigns, and it had demonstrated that victory in modern war is determined not only by battlefield courage or strategic genius, but by the unseen labor of millions working far from the front lines. The janitor's contribution, though modest, embodied this truth with perfect clarity. He was one among many whose quiet insight became part of a larger, unstoppable momentum, one that helped the Allies push across continents and bring the war to its end. What remained? after the doors closed and the echoes faded, was the understanding that history is shaped as much by ordinary people as by its most celebrated figures. The arsenal's walls had witnessed an industrial miracle, and within that miracle lived the countless small acts, some noticed, many forgotten, that together changed the course of a global conflict. In the calm that followed the war, when the noise of the factories softened and the newspapers moved on to post-war rebuilding, the story of how the United States outproduced its enemies often settled into a convenient narrative of massive machinery, brilliant engineers, and visionary leaders. Yet the truth, as always, is far more human. Victory did not emerge solely from grand strategy or technological prowess. It emerged from countless small acts of awareness, responsibility, and ingenuity carried out by ordinary people. The janitor's simple observation, born not from training or authority, but from presence and attention, represents the essence of that truth. He did not seek recognition, nor could he have imagined that his idea would ripple across the factory floor and eventually help shape the tempo of a global war. But history is full of such moments, quiet intersections where individual clarity meets collective need, producing outcomes far larger than the gesture itself. The Detroit Arsenal tank plant became a monument to what can happen when an entire society aligns itself toward a single purpose. It revealed that the strength of a nation rests not only in its leaders, but in its willingness to listen to the insights of those who see what others overlook. In wartime, this willingness meant the difference between hesitation and momentum, between shortages and abundance, between factories struggling to keep pace and factories producing with a speed that astonished the world. The janitor's contribution was a reminder that wisdom does not belong to titles, and that in moments of crisis, solutions may come from those who work closest to the ground, where the real conditions of life and labor unfold. Today, long after the last Sherman rolled off the line and decades after the arsenal ceased its wartime operations, the lesson endures. Innovation is rarely a thunderclap. More often, it is a whisper. It emerges from quiet observation, from humility, from the courage to speak when something seems wrong or wasteful or needlessly difficult. It emerges from people whose names history seldom records, yet whose actions shape events in ways they may never fully understand. The janitor's ridiculous shortcut was one such whisper, a small adjustment in a world racing against time, a subtle correction in the flow of steel and sweat that helped accelerate the march toward victory. And in that whisper lies a truth as relevant now as it was then. Sometimes the smallest insight, offered by the simplest of hands, can change the course of things far greater than itself.